Ready, set, go. Here we go. Today, we use the precise definition to prove that the limit as x goes to 2 of 3x plus 7 is equal to 13. So, we want to show that this is true using the precise definition. What does that mean? That means that we use the absolute value of f of x minus L is less than epsilon whenever absolute value of x minus a is less than delta. So let's write it out. Absolute value of what's f of x? 3x plus 7 minus what's L? 13 is less than epsilon. We aren't given an epsilon value. We're going to make epsilon so small, it's going to be 1 over infinity. Whenever x minus what's a? 2. Less than delta. We'll do when we get back. Go have lunch. Feed your brain. Okay, hope you had a good lunch. Here we are. We're trying to prove using the definition. This is the definition. So this is the first part to getting started. What? Wait a minute. You're fine. All right. So uh, at this point, what we need to do is to find an appropriate delta. That's what we've been doing the past 3 days, right? We've been finding delta values. So we need to find an appropriate delta given that statement above. How do we find an appropriate delta? We make the left side look like the right side. Like what? We make the left side look like the right side. It's as simple as that. So we have the absolute value of, how does this simplify right here? 3x minus 6 is less than epsilon. Does this look more like that now? What kind of factor out? If I factor a positive out of an absolute value, does that change anything? No, it doesn't. So take the 3 out, and I get x minus 2 less than epsilon. Is that looking more like that? Yeah. Now divide both sides by x minus 2 is less than epsilon over 3. So therefore, we can choose delta equal to, anybody know what delta should be equal to then? Epsilon over 3. So this work shows me that I choose delta to be epsilon over 3 because this looks like that, correct? Just instead of a delta, I have an epsilon over 3. So I made the right choice. I'm also going to make one statement. Because 3 delta is equal to epsilon. Are we okay with that statement? We know that 3 times the absolute value of x minus 2 is less than 3 delta. So all I did was I multiplied both sides of this by 3, right? I'm going to use that. In your proof, you have to write everything in blue. You don't have to write this red stuff. I'm writing this red stuff to help you understand the next statement. Okay? So, Great, color scheme has been saved. Thank you. So I have right here in front of us the first step. We found a delta. We're almost going to write the exact same thing over again. We're going to use our work, but we're going to make a mathematical statement. So our statement is this. Number 2. Show the absolute value of f of x minus L is less than epsilon when x minus a is less than delta. So I found an epsilon. I found a delta value that works, but now I want to show this statement to be true. You'll understand when we finish here exactly where all this comes from. So I will really just go back to my original work, and I'm going to write this again. Absolute value of, what is f of x? Minus 13. So right now, I'm focused on that. The next thing I have to come up with is an inequality sign in my statement. But I can't access an inequality sign yet because this doesn't look like anything up there that has an inequality sign. So I will use an equality sign. What is this equal to? 3x minus 6. Getting closer to something that has an inequality sign, which equals, what can I factor out? 3 times x minus 2. Oh, that looks good. You see my writing in red? What is that less than? 3 delta. I'm now ready to put that inequality sign in there. Less than, and as you guys said, 3 delta. Due to this right here. Now, what's the last thing I have to have for my statement to finish it off? An epsilon, correct? How do I get from 3 delta to epsilon? What can I plug in for delta? What is delta equal to? What do we choose our delta value to be? So we substitute epsilon over 3. What is 3 times epsilon over 3? And now you have to finish your proof. A box, done, QED, whatever you want. That's the statement of the proof. Let it sink in why this is true. We wanted to show that the absolute value of this was less than epsilon. Look at what I have in my proof. The absolute value piece, correct? Then through a series of equal signs, I was able to get to a less than. And then through a series of equal signs, I was able to get to an epsilon. See, I have those 3 pieces in that statement. That's what we were able to do. Okay. All right. Now that you've practiced one, let's do one together. It'll mean even more to you now. Limit as x goes to 4 of 3 minus 2x is equal to negative 5. Again, we use the absolute value of f of x minus L is less than epsilon when x minus a is less than delta. And now you're starting to remember this better because we're practicing it over and over, correct? So the first step is to what? Find an appropriate delta. How do we do that? we make the left side look like the right side. So I should have the absolute value of 3 minus 2x minus -5, so plus 5 is less than epsilon when x minus what? 4 is less than delta. Absolute value of what should I factor out to make the left side look like the right side? Not just 2, but I factor out a -2. When you multiply things together inside an absolute value, does the negative have any bearing towards the overall value? No, so when I take a negative out of the absolute value, it becomes a positive. So 2 times the absolute value of x minus 4 is less than epsilon. So absolute value of x minus 4 is less than what? Epsilon over 2. So choose epsilon, what? Choose delta equal to what? Epsilon over 2. That's our choice. What does that mean? Here's what it means. Suppose that epsilon was 2. What would delta be? 1. Suppose epsilon was equal to 0.5. What would delta be? 0.25, right? Suppose epsilon was 1 over infinity. What would delta be? 1 over twice infinity. We can make it infinitely small, and that's good news. So that means we could show it true for the smallest of windows. So we chose delta equal epsilon over 2. So I'm also going to make one more statement. I'm going to say that since absolute value of x minus 4 is less than delta, I say 2 times the absolute value of x minus 4 is less than 2 delta. So all I did was multiply that both sides by 2, and I'm going to use that in my statement coming up here. We're okay with me doing that? Okay, so see, absolute value of x minus 4 is less than delta. If you multiply both sides by 2, you get that. Because we're going to use it. And I'll show you why 2. Multiply both sides by 2 here, you get 2 delta. So I need to say something that has a 2 delta in it. Right? Epsilon is equal to 2 delta. So therefore, I wanted a statement that had a 2 delta. It's going to come up in my proof. I never used to write this 3 years ago, but then students didn't understand the last statement. I'm going to use this in my last statement. Step 2, show absolute value of f of x minus L is less than epsilon when x minus a is less than delta. So your first step was to choose an appropriate one for that. Now we want to show. So again, different operative words. First we choose, then we show. Absolute value of what? 3 minus 2x plus 5. Not ready to make an inequality sign yet, right? We're sitting right here. We're trying to show this. So what does that equal? You can use your work from above. What does it equal? 8 minus 2x, which equals, you could just factor out the 2. You don't have to show the negative. That's all right. It's assumed that in this class we would understand that. So 2 times the absolute value of x minus 4. I factored out a negative 2, became positive 2 outside the absolute value. Do I have that up here in my writing somewhere? Right here, correct? So Annika and Hannah, that's why I wrote this, because I knew I was going to come up with that. So I needed a statement about a 2 delta. So now I can substitute in my inequality sign, right? That's less than 2 delta. Well, I don't want a delta. I want an epsilon. So what do I substitute in for delta? Epsilon over 2. 2 times epsilon over 2. Epsilon. Again, you have this part. You have this part. Right here. 2 times delta. We chose delta to be epsilon over 2 because of our work here. So instead of a delta, I write epsilon over 2. I substituted that in. 2 times came from right here. 2 times x minus 4 is less than 2 times delta. I mean, if it's illegal to multiply both sides of an inequality by 2, right? So I just manipulate the inequality so it would show up here. Done. So I have my inequality sign. I have my epsilon sign. All the pieces are there. I made my statement. I chose it, and then I showed it. Showed. Is that proper English? Thank you. Okay. 2.4, page 101, numbers 15, 17, and 18. So this continues off your assignment from yesterday. So if you look at your assignment from yesterday, you just flip it over, and the problems are there. Eli did make a good point about the English. I want you to know that when I took this class in college, um, so when we did these type of proofs, it was in an analysis course, and the professor had a doctorate in mathematics and had a doctorate in English. So first he would go through and make sure everything was mathematically correct, and he would go through it again and make sure everything was grammatically correct. And if it wasn't, you redid it. We got a writing credit for that math course because all we did was write proofs. But the first time I saw these type of proofs was actually back in my pre-calculus course in high school. We did take some time to go over it. So it's good that you see it now. Don't be scared of it someday if you do see it.